Okay, I'm going to give you some advice here for this question that makes me a little nervous that you're going to just kind of take it and run with it and it's going to cause you problems down the road. The main theme here is that we want to get back to basics. So if we see this system here of inequalities, we should know that the SAT does test regular old systems of equations fairly often, and that they don't usually have inequalities. And so getting back to basics would mean, can we do away with this twisted version of it? Can we do away with the inequalities? And on the SAT, a lot of the time, this is the advice I'm nervous about, a lot of the time when you have inequalities, you can just like pretend that they're not there. And you can just take these equations, just be like, okay, let's just pretend it's y equals negative 15x plus 3,000 and y equals 5x. And ignore the inequality. Let's just do that for now. Let's just take my word for it and see what happens. So now I have a system, and hopefully we know enough about systems to be like, all right, I got to mix these two equations together, and I got to do it in a way that gets rid of one of the variables. And since they're both set to y equals, we can make an easy substitution, and we would end up with 5x is equal to negative 15x plus 3,000. And so, okay, let's add 15x to both sides. And we get 20x is equal to 3,000. And we're going to divide by 20 to find x is equal to, let's use the calculator, might as well, too many zeros floating around there, 150. Now, they're asking for b, right? And if we look at the way that it's presented here, b is in the y position. So this is pretty simple. Let's just plug x into one of these equations and solve for y. So I'm going to go all the way back to this equation. So y is equal to 5 times 150. 5 times 150 is 750, which is actually the answer. Okay, so I said ignore the inequality, pretend it doesn't exist, and it usually works out, and it worked out. So good. And for many of you, that advice is probably just good enough advice that you can follow it in a lot of cases. If it doesn't seem to work, then you probably are still going to somehow eliminate some answers if it's multiple choice, or you can always bring the inequality back in. So sometimes the inequality does matter, so you can't just ignore it completely, but a lot of times it doesn't, and this is a good kind of example of that. Let me show you why it doesn't matter, and maybe that will help you know when you can follow my advice and when you shouldn't. The key piece here is that it says in the question that we need the maximum possible value of b, or y. So if we were to graph these two equations, I'm just going to make a rough sketch here. Let's do the y equals 5x first. That would be going through the origin and have a steep slope. So I'm going to make it look kind of like this. So this is this one. And the other one we'll do in green. That's going to be this guy. So that's got a high y-intercept and then a negative slope. So let's just kind of do this. Okay. And because both of them are written in this form y equals mx plus b, basically, when we shade the solutions for each of these, when we shade the inequality, we're able to think vertically because the y is isolated. So we can think, okay, the y has to be less than the line. So where's y going to be less than my line? It's going to be below the line. So for green, I'm going to shade down from my line. And for red, same thing. Look, it's less than 5x, so I'm going to shade below the line. And so I just want to really make it clear. The shaded region where these two things overlap is what we're interested in. So it basically forms a triangle. It's kind of messy, but it's okay. The sketch is good enough here. And so the values of x and y, of a and b, that work, that are considered solutions, are in that yellow area. Okay, there's an infinite number of them, right? So that's overwhelming, but we don't care about all of them. We care about one of them, the maximum possible value of y. And now you have to think of that highlighted area as like a mountain, right? So where's the highest point of the mountain? It's the peak, okay? The peak. And what's going on at the peak? Well, the peak is where the two lines themselves meet, right? It's the actual point of intersection between the lines. Ignoring the inequality, It's where the lines themselves cross, not just where the shaded areas cross, the lines themselves. And if we had written these just as lines and ignored the inequality, we would have solved for that point using a system of equations with equal signs. So this is why my advice is justified. I don't think you need to understand that to, in a pinch, just drop the inequalities, pretend they're equal signs, and do whatever seems most obvious in the situation. So the reason I give this advice is that it's a quick way of maybe making one of these complicated looking questions much, much easier. Because if we have equal signs, we understand algebra better, and we're more able to kind of just like move through the process and solve for X or Y or whatever. The reason I'm hesitant is that there will be times where the inequality matters. And so this won't work every time. But if you're stuck, if you're running out of time, if you're confused, good advice, drop the inequality, see what happens, pretend it's an equal sign, and you might be able to solve. At the very least, you might be able to eliminate some answers and then hopefully figure it out from there. So best of luck, but you've been warned. It's not going to work every time, so don't hold it against me if it causes a problem. It will work a lot, but as so often happens on the SAT, there's always exceptions.